Hello everyone. Uh, this is a voiceover video presentation on massive multiplayer games on peer-to-peer structures. There will be three speakers in this video, including myself. It is Archit, and second one is Yuvatong, and the third one is Kyaner. We are presenting here how we can support massive multiplayer games on peer-to-peer overlays. Our approach exploits the fact uh, that the players in MMGs display locality of interest and therefore can form self-organizing groups based on their locations in the virtual world. To this end, we have designed scalable mechanisms to distribute game state to the participating players and to maintain consistency in the face of node failures. So now we're at the introduction. Uh, we propose the use of peer-to-peer overlays to support massive multiplayer games on the internet. Now, what does that mean? That means that these massive games can be distributed over players' machines, and players participating in the games form an overlay on which many of the game functions are implemented. Um, the players can contribute from anything to everything, and you can say that can be memory, um, CPU cycles, and bandwidth to manage shared game state. The most concurrent players you can have on these massive overlays is over 180,000 players online at once, and that's a big amount of load. So the reason I emphasize on the big amount of load is that initially these games are supported by the traditional client server architectures, where the server keeps both player account information and handles the game state. Um, the you can achieve scalability on these structures just by increasing the number of servers. And in the one way you can do that in a really neat trick, it's called employing server clusters, where you make the clusters of the server, and these servers can be connected by LANs, or they could form a computing grid. Although these structures scales with number of players, it lacks flexibility, and the server has to be over provisioned to handle peak loads. And that's one of the biggest drawbacks for these structures, the client servers. So now we have over the fact that we don't need the client servers architecture anymore. We note that games utilize the memory and CPU cycles of the peers to maintain the shared game state. And with this idea, there are some potential problems that must be addressed to make our peer to peer approach fully solid. The one that first comes to mind is the performance. As the game goes or the continues, it needs to be constantly updated. By that I mean is if you're in a battle with someone and you hit someone, then it needs to go instantly. Like it should not be delayed. And this gives us one more constraint, that is time, that the message needed to be received within a time frame. The second one is the availability. Uh, so we are replicating game states in every one of the player's computer, and this has potentially two problems. First, if a peer goes offline, the state quickly becomes invalid. And the second one, because of the high update frequency, maintaining a large set of replica is a potential performance bottleneck. And the last problem that we need to think about is the security. We need to think about how we can prevent account theft and cheating during the gameplay. As we distribute the shared game state to the peers, it very much increases the opportunities for cheating. You can very easily capture the account data of the person you're engaging in battle with because all the data regarding that person is on your machine. So, right off the bat, one solution that comes to mind is we centralize the accounts. That is, we implement the client server architecture just for the accounts, and for the gameplay, we still keep the peer to peer structure. The key feasibility of the peer to peer game architecture is the locality of interest. And at any given time, the amount of area of interest by a single player covered is limited. And as a result of that, the players can be arranged into the groups of same interest. And we'll see further in the paper that this is one of the main key points on how we can organize players into the peer to peer structures.
We build this peer-to-peer infrastructure on top of Pastry and Scrap. The can core tapestry pastry-like overlay contains property like self-repairing and decentralizing. They also offer scalable distributed hash table by mapping reliable given key to a unique lim node in the network. The game design uses the transient game state on a P2P overlay operating by the central server to delegate bandwidth and manage processing game states. This design is related to the temporal and spatial localities. We're looking forward the design can localize communication and the interest management in an application dependency. The game state must be consistent among players in the same region. For example, player A drink half of a bottle of wine. Player B, who later arrives at the scene, will only be able to drink the remaining half. In a P2P overlay, we separate players by mapping them to pastry key space. Although the coordinator of region is lake, but the lack of locality is benefits for reducing cheating opportunity and avoiding loss of region state. The fault tolerance is required by every game. Assuming the connection is crashed, we want to make sure the fault tolerance and the efficient failover. Both pastry and scrap have the fault tolerance. We make some extension here. First, the independent nodes. Independent nodes could ensure that no correlation between nodes. Second, cracked rooted nodes. which means we routed the nodes to closest key, and it makes lower fail frequency. Last but not least, backup. We are making a dynamic replication to prevent loss of data. Once the failure happens, we could replicate the state immediately. This allows data transfer between old and new nodes, and keep the game progress go on wheels.
Hello everyone, my name is Yuan Tongguo, and today I'm going to do the presentation for MMOG on P2P. First, let's talk about what is MMOG. Massive multiplayer online games with their virtual gaming worlds, growth in user numbers, as well as the size of the virtual worlds. With this growth comes a significant increase of the requirements for server hardware. Today, an MMOG provider usually faces the problem of serving thousands of users with entire service clusters. Peer-to-peer networks, with their high scalability and flexibility, meet the requirements of connecting hundreds of thousands of people all over the world without certain servers. In doing so, the network bandwidth requirements remain at a reasonable level. In this work, we propose to combine MMOGs with a peer-to-peer network. We introduce a game architecture capable of exploiting the flexibility and scalability of P2P networks. A P2P architecture based on an overlay network using distributed hash tables with support for persistent object storage and event distribution has been developed to meet MMOG requirements. For the discussion, scalability, first one is the scalability, which is one of the common issues in peer-to-peer network. We have designed our topology with the ability to organize itself efficiency to reduce the inherent scalability problems. For the network efficiency is reducing the load of network traffic. And for the data storage, P2P network must storage a large amount of redundant data so that the game can still function with a minimum number of players. For the processing in a P2P game of any sort, it is important for each node not to trust any other node. For the game or function, calculations must be carried out at some point. For the communication system implement, the purpose of the communication system is to provide the game with a way to communicate with other peers over the network. And also it allows passing information between games peers, such as requesting information about games and updating players' information. For the conclusions and future work, massively multiplayer online games have rapidly grown in popularity. Our protocol offers a fully distributed, fault-tolerant, and scalable solution to MMOG. However, further research needs to be done on making a viable distributed game over a pure P2P overlay. For our future work, we will involve the development of an agent based on MMOG simulator to test hundreds of simulated players, and also using different transport protocols. Assumes uniform latency for now, testing games with more status and on global distributed network platforms and also it could use for stop cheating by detection. That's it. Thank you.